Now we proceed to inductors. So, ano naman yung mga property, current voltage relationship ng inductor? So, an inductor is a passive element designed to store energy in its magnetic field. They are used in power supplies, transformers, radios, TV, radar, and electric motors. So, ito yung mga tsura ng mga various types of inductors natin. Any inductor of electric current has inductive properties and may be regarded as an inductor. But in order to enhance the inductive effect of a practical inductor, it is usually formed into a cylindrical coil, parang ganito. Ayan, forms into cylindrical coil with many turns of conducting wire as shown in this figure. Okay, if the current is allowed, okay, so kung if current is allowed to pass through an inductor, so for example, meron tayong current that will pass through the inductor. Ayan. Okay, it is found that the voltage, across the inductor, is directly proportional to the time rate of change of current. So, time rate of change of current. So, para tanggalin natin yung proportionality symbol natin, we have to introduce a constant, and that constant is, yung K constant natin is, that is the inductance of the material. So, inductance is the property whereby an inductor exhibits opposition to the change of current flowing through it, and it is measured in Henry, or that is H, named after Joseph Henry. So, ito yung unang equation natin. V, the voltage across an inductor when a current passes through it, is equal to the inductance multiplied by the time rate of change of the current. So, L here is the inductance, and again, it is named after Joseph Henry. Ang value ngayon ng L natin, so kung titignan natin, so L cross-multiply natin, no? L cross-multiply natin ito doon. So, that is V dt over di. So, 1 Henry is equivalent to, 1 Henry is equivalent to 1 volt. 1 volt second, kasi time yun, dt, per ampere. Ay, wait. This is di, sorry. Ayan. So, L is equal to dt times V, dt over di. Ayan. So, per ampere. So, Henry is 1 volt second per ampere. Okay. So, like in the case of capacitance, although the inductance is equivalent to 1 volt second per ampere, but it does not depend on the voltage across the inductor. Rather, it depends on the physical dimension and construction of the inductor. Kamukha siya ng capacitance. So, ano ba yung physical dimension and construction na sinasabi ko? The derivation of the inductor or the derivation for calculating the inductance of inductors of different shapes are from electromagnetic theory. So, one example is this one. It is actually the inductance of a solenoid inductor, which is equivalent to N squared mu times A over L, wherein N is the number of turns, L is the length, A is the cross-sectional area, and mu is the permeability of the core. Nasa table yan. What we can conclude here, or generalize, is that for us to have an increased value of inductance, so kailangan increase natin yung number of turns, the permeability, and the cross-sectional area. Okay, or by reducing the length of the coil. Okay, so ano yung una nating formula? Voltage across a inductor is equal to L, the inductance, multiplied by the time rate of change of current. Okay. Graphically, ito yung ating figure for or representation for this equation. Kamukha din siya dun sa capacitance. Yung I is equal to C dV over dt. But in this case, our y-axis is V, yung ating x-axis is di over dt, and L is the slope. Diba yan? Y is equal to mx plus b. Since the intercept or intersection of the line in the y-axis is 0, kaya y is equal to mx, y is dv, and x is di over dt, while m is the slope. The slope determines the inductance of the coil or the material. Okay, kailangan natin din makuha yung current voltage relationship ng inductor natin. So, mag-umpisa tayo sa equation na V is equal to, yung una-una nating equation, di over dt. And then, we have to find the I, a voltage relationship, I as a function of V. Yan yung goal natin. So, ito, mag-i-stay siya dyan. Ito yon V dt over L, or that is, L is constant, 1 over L, V dt. And then, we integrate both sides. So, that is I, 1 over L, time interval, negative infinity to time t, V as a function of time dt. Ayan. But, to avoid confusions, i-ano natin tong negative t, no? I is equal to 1 over L from time 0 to time t, V of t dt. Plus, syempre, kailangan, kasi current ito. So, kung kukunin natin yung past or yung history ng ating inductor, kailangan natin makuha yung value of current at time equals 0. So, ito yung equation natin. Ayan. So, kamukha rin siya. Where I of T sub O is the total current, ito yung past or history of the value ng inductor natin, current value of the inductor from time negative infinity to time 0. And we assume that I of negative T is equal to 0. Perhaps, or the idea of making I of negative infinity equals 0 is because there must be a time in the past where there is no current in the inductor. So, kaya ganyan siya.